All right, everybody. Today we are going to look at exponential functions. Very fun topic here. So, exponential functions, well, they come in this general form. I'll go ahead and write it here. It is f of x, or y, equals a times b raised to the power of x plus k. A, b, and k, a, b, and k, these are all just integers or numbers. So these are just normal numbers, and I'll just put numbers here. Sometimes that word integers, that can confuse you, very weird. But a, b, and k are integers. Of course, x is your variable or unknown. So this is variable. And the trick about these is that the exponent now is your variable rather than having something like y equals x or y equals x squared. Now we have y equals 2 raised to the x, and the x is in the exponent. So I have an example here, and it is 2 to the x. This is the parent function or most basic function. I'll go ahead and write that. There are some other ways. There's some debate over what you could have as a parent function here, but usually we'll call this the parent function. It's 2 to the x. Well, what if x is negative 3? Well, that's going to be 2 raised to the negative 3, which is 1 over 2 to the 3, which is 1 over 8. All right? And same thing, if we fill in this table, 2 to the negative 2 is 1 over 2 squared, which is 1 over 4. 2 times 2 being 4. 2 to the negative 1 is going to give me 1 over 2 to the 1, which is just 1 over 2. And 2 to the 0, of course, that just gives me 1. Anything raised to the 0 power is 1. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the cubed. 2 cubed is 8. And 2 to the 4 is 16. And as we go, 5, this is going to give me 32. This number is going to keep doubling. So you can see these are going to get very big. What is that, 128? Very quickly. So 256, and then we'll get 512, and then 1024, and then 2048. And that's just going to 9, 10, 11. So this number is not getting that big so quickly. We're just going by ones, but you can see this number starts jumping into the hundreds and thousands very, very quickly. So if I were to graph this, it looks kind of like this, where the first thing in the base function we're going to look at is right here, which is the y-intercept, and it generally is 0, 1, because of course anything raised to the 0 power is 1. Now there are some alterations we can make to that, namely we could multiply it or add to it, but looks kind of like this. And what happens here is this number gets smaller and smaller and smaller, but it'll never get to be negative. So we have something here on the line here, right, where it is the x-axis, where the function is going to get closer and closer and closer to the x-axis. So if this is your function and this is your x-axis, well, it's going to get halfway, and then it's going to get halfway again, and then halfway, and halfway, and halfway. And it's, in theory, it'll never touch, but it's always going to get closer and closer, because no matter how close we get, we can divide in two and go half the way, half the distance, right? So this is called an asymptote. So that's a fun new vocabulary word for us. All right, so today we're going to look at two parts of an exponential function. The first being the domain, and I'll just tell you the big secret here. The domain of all of these exponential functions that we will deal with are going to be all real numbers, because they will go to the left forever and they will go to the right forever. So the domain always going to be all real numbers. So if you see a question on the quiz and it says, what is the domain of this function? I'm just telling you, it's all real numbers. So you don't have to worry too much about those. Now, the other one is the range, of course. And the range is a little bit more tricky. And what it's going to be, well, we're going to really look at this k. Because that k is our Mr. Elevator, and it's going to move our function up and down. So, for example, let's say we had a function like this and came through here like that. And let's just say this was f of x equals 2 to the x, right? Well, if I come in now and I write, let me put my labels on my axis, f of x equals 2 to the x plus 1. So, well, yes, 2 to the 0, of course, is still 1, but now I'm saying 1 plus 1. So now, this guy is going to come, the y-intercept is going to be here, but this is still, now, the problem is here, though, no matter how small this gets, even if this is negative 100, it's 2 to the negative 100 plus 1. So this number will essentially become nothing, but this guy is still going to be 1, so it will never get below that line of y equals 1. So my range here would be x. Well, x is, of course, all real numbers. I'm sorry, y. Y is going to be greater than 1. Now, can it be equal to 1? No, because it will never touch that line. Again, it's going to go halfway and halfway and halfway, but it'll always be above 1. So what you're looking at here is essentially that letter k. When we look at our range, well, if I have y equals, I'll just put the standard form here, a to the a times b raised to the x plus k. Well, y is always going to be greater than k. And there's one exception to that, and that is if a just happens to be negative. So if, let me just go here, I'll write this again, f of x equals a times b raised to the x plus k. Well, if a is negative, what happens? Well, if a is a negative number, well, it's going to flip this guy around. So now, instead of having my function like this, where it's coming up, well, now it gets mirrored around the x-axis. And so it would be less than. So in this case, I would say my range is going to be y is, instead of greater than, it's going to be less than whatever that letter k is. Generally, k will be 0, but there are times, of course, where k will be some other number, and you'll see that in some example problems. But that's it for domain and range. Next time, I guess we'll look at the asymptote and y-intercept.